In this video, let us continue to solve problems based on surface areas and volumes. So we've got a question here which reads like this. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area and volume of the resulting cuboid. Well, as far as the volume of the resulting cuboid is concerned, I think it's pretty simple that, if you add two things of some volume, you just have to add their volumes to get the resulting volume. Because you're not going to lose anything anywhere when you join them, right? So it's going to be 128 centimeter cube, right? So anyways, let's check it when we, solve it, however we're supposed to actually solve it. So, but otherwise it's pretty logical, the volume is fine. Only thing we have to break our heads about the surface area. Otherwise, the question is pretty much very simple. Two cubes of 64 centimeter cube when joined is going to give you 128 centimeter cube. Nothing more, nothing less. So let me give you an illustration of this, two cubes being joined and all. This is one cube. And then another cube which is going to be joined is going to be something like this. So yeah, here it is pretty simple actually. So I hope you can picturize this as two cubes, two cubes joined, and you can see that the volume is 64 centimeter cube each, right? So now let's write the given data. The volume equals 64 centimeter cube. So what should be the side? What should be the measurement of each edge? So let us say each edge is x centimeters. So it's going to be x cube equals 64, right? So x cube equals what? 4 cube, because 4 times 4 is 16 and 16 times 4 is 64. So that's why I'm writing it as 4 cube. Now, if x cube equals 4 cube, then x equals 4. The laws of indices. Please go back to those topics if you haven't understood this concept. So we've got x equals 4 here. So that means each edge is equal to 4 centimeters. So this is going to be 4. So this is going to be 4, right? So the height is going to be 4. And what else? We've got the breadth, right? So this is going to be 4. So everything's going to be 4. Only this length, after it's joined, it's going to become 8. So it's going to become a cuboid of length 8 centimeters. And then, height is 4 centimeters. Breadth is going to be still 4 centimeters because there's no difference there. So now the new dimensions, cuboid. Listen carefully. It's cuboid, not cube anymore. Cube is something which is equal. Cuboid is like a rectangular cube, something like that. So the dimension of the cuboid is going to be, length is going to become 8 centimeters, this one. Otherwise, it's going to be the same. Breadth is going to be 4 centimeters and height is also going to be 4 centimeters. No changes here. Okay. So now we've got LBH. All that we have to do is just substitute this in the formula, that is the surface area formula. The surface area of a cuboid is given by 2 times length into breadth plus breadth into height plus height into length, right? So you're going to 2 times 8 into 4 plus 4 times 4 plus 8 times 4 again. The L is 8 and the H is 4. So I just interchanged it. So please notice that. 8 times 4 is 32, 4 times 4 is 16, and 8 times 4 is 32 again. So adding this, 32 plus 32 gives you 64. 64 plus 16 gives you 80. 2 times 80 is 160 centimeters squared. So therefore, the surface area of the newly formed cuboid is 160 centimeters squared. All right. So the volume, trust me, it's going to be 128. 64 here and 64 here, you combine them, it's obviously going to become double, right? It's going to be 128. So anyways, let's work it out. The volume is going to be LBH. So L is 8, B is 4, and H is 4. So 8 times 4 is 32, and 32 times 4 is 128. So the volume is 128 centimeter cube. So therefore, the surface area of the resulting cuboid is 160 centimeters square, and the volume of the resulting cuboid is 128 centimeter cube. So that's all there is to do in this problem. This ends this video. I'll see you in the forthcoming videos with more problems based on surface areas and volumes.